Hello and welcome back to Introduction to Astronomy. And in our previous segment we were talking about angular momentum. So here's a sample question that involves angular momentum. What happens to the speed of a planet the closer it gets to the sun? So a planet goes around a star in an ellipse. So that means sometimes the planet's going to be further out and sometimes it's going to be closer to the sun, the star, whatever it's in orbit around. So in this particular case, let's imagine that the planet is out here so that the R is large, okay? And let's say that it has a certain V, so it has a certain angular momentum, which would be the distance R times the mass of the planet times the speed of the planet as it goes around. So let's say that it's R and then times m times v. Now it's going to orbit over to here, so the R is going to get smaller. So if the R gets smaller, then the V is going to get bigger in order to compensate. So think about 4 is equal to 1 times 4, or it's equal to 4 times 1. So a big number times a small number can be the same as a small number times a big number. So again, the closer it gets, the R gets small, but the V would get bigger in order to compensate. So let's kind of summarize here. Comparing linear motion to rotational motion. So you've got linear speed, which is sideways speed given by V, and then you've got rotational speed, which is given by omega, which is that W looking thing. Now when the speed of an object changes in time, we call that acceleration. So you have linear acceleration when something accelerates sideways, and then you also have rotational acceleration, and that's going to be given by the Greek letter A, which is alpha. Okay, now what's causing the acceleration is going to be the force. And so you have linear force, and then you also have rotational force, which we call torque or a twist. Okay, then you're going to have what resists motion when you're going sideways, and that's the mass of the object. And then you also have the rotational inertia, which is called the moment of inertia, I, which resists when you try to spin something. And then there's two kinds of momentum. So you've got linear momentum when something's going sideways, and then you got angular momentum when something's rotating. All right, now we're going to switch gears, and in our next segment, we're going to be talking about energy. So I'll see you then.